Okay, good morning, everyone. This is day 2 of section 8.6, radical expressions and rational exponents. Today we'll be working with properties of rational exponents, but it really is no different than the properties we learned when we worked with integer exponents. So I'll just review a couple of those to recall. The product of powers property says that when you multiply two powers, like 2 to the third times 2 to the fourth, you add the exponents. So that would be 2 raised to the 3 plus 4, which is 2 to the 7th, which would be, let's see here, if I believe that would be 128. Yep, that would be 128. And then when we divide a power by a power, so for example, 2 to the second divided by 2 to the fourth, we subtract exponents, so that would be 2 raised to 2 minus 4, which is equal to 2 raised to negative 2. But to recall, to make the exponent positive, you take the reciprocal of the base, so 2 over 1, which will be 1 over 2, and we raise 2 to the second power, positive 2, and that would be 1 over 4. Okay, so same properties, but now we're working with rational exponents rather than integer exponents. So same properties. So the product of powers property. So they give us an example here that we have 12 raised to 1/2 times 12 raised to 3/2, and 1/2 plus 3/2, well, that would be 4/2. And then 4/2 is 2, so 12 squared is 144. Again, a raised to the m times a raised to the n is equal to a raised to the m plus n. Another example here, I have 7 raised to the 7th ninth times 7 raised to the 11th ninth. So that would be 7 raised to the 7th ninth plus 11 ninths. And that will equal 7 raised to the 18th ninths, which is 7 squared, which will be 49. That's the products of powers property. Quotient of powers property says that when you take a power and divide it by a power, you subtract the exponents. So we have 125 raised to 2/3 divided by 125 raised to the 1/3. 2/3 minus 1/3 gives you 1/3. And then the cube root of 125 is 5. Again, when you take a power and divide it by a power, you subtract the exponents. In this example here, I have 16 raised to 3/4 divided by 16 raised to 5/4. So this would be 16 raised to 3/4 minus 5/4. And this would be 16 raised to the minus 2/4, which I can simplify as 16 raised to the minus 1/2. And that will be equal to the square root of 16 raised to the minus 1, which would be equal to 4 raised to the minus 1, which will equal 1 over 4. Okay. The next one here. So I guess this would be illustrative of the power of a power property. We just distribute exponents to exponents here. So here they give us 8 raised to 2/3 raised to the 3rd. So you multiply 2/3 times 3, and that will give you 2, and then 8 squared is 64. Well, I guess in this case here, okay, my exponent there is 1. So when I take 1 and multiply it by negative 2/3, I'll get the same thing. So nothing really changes here. I'll just have negative 27 raised to the negative 2/3. Okay, but this here, as we learned yesterday, that will be the cube root of negative 27, and then we'll raise that to the negative 2. And so the cube root of negative 27 will be negative 3. We'll raise that to the negative 2. You take the reciprocal of negative 3 over 1, which will be 1 over negative 3. And then we'll raise it to the positive power, and that will give us 1 over 9. Okay, the next one here. So notice here I'm taking a fraction and I'm raising it to a negative exponent, so I'll just take the reciprocal of 8 over 27, which will be 27 over 8, and then raise everything to the positive power 2/3, and then I'll distribute the exponents to exponents. So 2/3 times 1 will be 2/3, so this will be 27 raised to the 2/3, and then 2/3 times 1 will be 2/3, so 8 raised to 2/3, and that will equal the cube root of 27 squared over the cube root of 8 squared, and the cube root of 27 is 3, so that will equal 3 squared, and the cube root of 8 is 2 squared, and that will equal the 9 over 4. And then the last one, again, we just distribute exponents to exponents. So I'll distribute the 9 to the 1/3. So that will be 3 and 9/3, which is just 3 squared, which is just 9. So again, working with rational exponents that involve fractions is really no different than working with integer exponents, okay? The properties hold. So in that sense, nothing new under the sun.